everyone. This is Adam Sandman here. I'll be today's presenter on today's webinar. We'll be talking about AI and software delivery, how to adapt, together with some cool live examples of how AI is changing the software development lifecycle. Today, we'll be talking about how you can use AI across the software lifecycle, how it's changing everything in particular, not just development and chatbots. AI seems to be, right now, Gen AI seems to be mainly chatbots, marketing, and coding tools. And what we're seeing is there's a much larger need for AI across the life cycle, which I'm going to talk about. Then we're going to talk about the Spyro platform and Rapidus platforms from Inflectra and how we are currently incorporating AI into those tools, and also some of our future plans. As I mentioned, my name is Adam Sandman. I'm the founder and CEO of Inflectra. I've been in this industry for 18 years. It's hard to imagine sometimes. Working at Inflectra specifically. Before that, I was a director of technology at Sapient doing IT services. That's where I realized that software testing and development and lifecycle management was something that really needed help, and founded a company to make that better. I've been doing this for a while. So one thing I wanted to mention about AI, anything we talk about today will be obsolete in about a month, if not before. So please take that. If you're watching this recording and it's in 2025 and you're like, wow, some of this stuff is out of date, well, that's Gen AI for you. This presentation I gave, similar one about 6 months ago, maybe 5 months ago in June, and it's already out of date. So this is updated as of the latest information we have, but it will be out of date probably in a few months. So at Inflectra, just for those who are new to the company, have not heard of us before, Inflectra, we're all about quality. And we believe that with the advent of Gen AI, quality is more important than ever. It's always been important, but now it's more important than ever. So at Inflectra, we don't want a single point of failure for you or for us. We don't want systems going down. The world relies more and more on software. I mean, we saw this in dramatic fashion without picking on a particular company, but when CrowdStrike went down and airlines, trains, power plants, healthcare all went down in a single stroke, we realized there was a single point of failure, one configuration file that was changed. So we are very vulnerable as a society on IT and IT failure, and we are using AI, and thus quality is paramount. And we believe at Inflectra, if you have the right tools and processes and a culture of quality, you can deliver quality at speed, at scale, and have manageable risk. And we want to help you do that. Some of the benefits of the Inflectra platform, I won't go through all this, but we do help you, reduce the time spent on quality escapes, dealing with, fixing bugs, redoing releases, redeploying, undeploying, all of the bad things that happen when quality gets out into production or lack of quality. Also, we want to improve productivity. So software testing is not the bottleneck that it usually is. Requirements management, process management. They say that developers spend 5% of their time developing and 95% doing other things. And if coding is going to get more efficient, those other things are going to take even longer. We want to make sure that you can do those management tasks, quality tasks, compliance things, do it fast and do it safely. Here are some of the customers that we have across some of our key industries. So we do work with medium to large companies around the world. You look here, you can see companies that when their systems go down, bad things happen. So they do rely on our software and our platform to ensure the world and their business runs safely. So we do take this very seriously, as they do too. And as a company, we really want to bridge this world using our platform. Today, I'm going to be showing you a couple of different tools, but we want to bridge the world of agile delivery and compliance, regulation, and safety. So we want to make things fast with, continuous development, continuous deployment, DevOps, agile. Everything on the right-hand side of this diagram are things that the development side can deal with. But on the other hand, on the left-hand side, we need to make sure we're compliant with all the rules and regulations of when we deploy software. Are we meeting our SOC 2 or ISO 27001 security requirements? Are we meeting our ISO 9001 quality requirements? Do we meet our regulations for life sciences, banking, manufacturing, whatever industry you're working in? There's increasing regulation around software because we recognize how important it is, how critical it is for the world and the industry we work in. And thus, the left-hand side is slowing down the right-hand side. And in Inflectra, our products help you increase productivity across the entire life cycle from left and the right-hand side. So let's talk about AI next. That's why we're here for. That's what we're here for. AI is transforming software development. I was very fortunate last week to be at the AWS reInvent Summit in Las Vegas, which was a lot of fun, very tiring. So I'm a little tired this week. We did have a great report from McKinsey about how software development is changing the life cycle. Sorry, AI is changing the software development life cycle, where they're seeing current use cases and where there's a big lag. So it aligns very closely with what we're talking about today. So if this is our famous DevOps infinity loop, we create things, we plan them, we develop them, we verify them, we package them, release them, configure them, and monitor them. If you look in here, coding is one small piece of this. It's part of, I guess you'd say it's part of create. And yet, when we look at AI, really we're not applying AI across the entire life cycle that we should. We're mostly been applying it in the create phase. So you'll hear about tools like Amazon Q, Windows Visual Studio, Copilot. Members of our team have been playing around with Gemini as well as an option. So there's plenty of coding assistance out there. That's just the green box that you see says create. What about planning? What about verification, packaging, releasing, configuring, and monitoring, where many of the problems occur? One of the challenges will be, how do we keep the life cycle, the cadence of the life cycle consistent? If we're making one part faster, that's just creating new bottlenecks. So as well as the bottlenecks, there's a secondary problem. One of the things that was interesting, this is from a graph from a friend of mine, Andrew Palmer of Fujitsu, it's on LinkedIn. Since ChatGPT was released, the number of people viewing Stack Overflow and other similar websites has decreased massively. And we're now seeing people use coding tools like Amazon Q, Copilot, and so on, at increasing amounts. And even ChatGPT and Gemini and non-coding tools can do coding tasks. And what we're finding is, as more and more people are using these tools, there is a 300% increase in productivity. I think Google is saying that 20, 30, 40% of their code is now AI written, which is great. But we are seeing, apparently, according to some studies that were done by one of our partners, we are seeing a 400% quality decrease. So we are creating more code, which is great, fantastic, but it's not as good, not so good. And it's also, again, we're getting this code is being ingested from AI sites like Stack Overflow, but people won't be contributing as much because there's no one reading it. So it becomes a negative feedback loop in terms of the quality of what's out there as well. So what does that mean for us? Well, it means if we're turbocharging software development productivity, but we're therefore creating bottlenecks in other phases, testing, validation, documentation, planning, monitoring, everything that you do that's not software development. And as the McKinsey report says, I think only 5% of developers' time is spent on coding. So the other 95% is going to become more of a bottleneck. So the question is, how do we supercharge the rest of the software lifecycle to keep up? Another related problem is that AI systems, where you're actually building an AI system, the requirements aren't as well defined because the system itself is learned from training data. How do you write a user story for a system that has learned how to function from training data? Well, we don't. So if the requirements are fuzzier and potentially non-specific and non-deterministic, then the tests themselves are more difficult, and yet the code volume is increasing and the requirements are fuzzier. This seems like a recipe for disaster. So we need to supercharge the rest of the software lifecycle to keep up with this. Now, in testing, which is partly why we're here today, it's one of the features we'll be showing, not the only ones. How mature is the adoption of AI? Well, this comes from the Planet Global Quality Index report. Planet's one of our partners in the UK and Australia, and they've been talking a lot about quality, and they did this quality report, which is great. So the good thing is customers are starting to look at AI. 40% are currently using AI, generative AI, and 60% are not. So 40%, okay, that's not so bad. But when you actually look at that 40%, it's not exactly 40% using it. It's really 26%, and only 14% are planning it. So really, it's about a quarter are actively using it. The rest are just playing around, doing pilots and POCs. And of the other 60% that are not using it, many have no plans for using it. So it's even more negative than that. So there's definitely a gap between those that are using it. A quarter are using it. 3/4 are either not using it, partly, trying it, not using it, and not trying it. or not ever planning on trying it and using it, depending on that spectrum. So that's a problem. 75% or 74% really are not using it. But on the coding side, we know that more and more people are using it for development. So there's imbalance between the different parts of the life cycle. Okay, so what can we help you with? What can we, what can we use AI for? There's lots of things that AI can do, and it's incredibly powerful. And it's amazing how some of these simple use cases can deliver incredible productivity gains. First thing is we can use it to write BDD scenarios. We can use it to write manual test cases, right? These are very tedious tasks. We can figure out what might be some risks in our system. We can write code. We can write developer tasks. We can write unit tests. We can push them into a pipeline. We can potentially have it do automated testing of our application, not just the unit testing, but also some of the UI testing and API testing. Maybe it can generate documentation. It can conduct audits for us. So there's lots of really important things that it can do to help us. And in Fletcher, we are really committed to helping you do a lot of this with AI in a safe way. What I'm going to show you today in the live application is just what's live today. It's not the full suite of what's going to be coming. We are working very closely with AWS, which is our strategic technical partner, in releasing more and more AI functionality, but with safety. We'll be using features like AWS guardrails to make sure that the data that you give us is safe, that the prompts are safe, that the data coming back has been validated and tested, and that AI is not hallucinating and causing crazy results. So AI is a tool that should be used with care. We want to make sure we make it safe for you, our customers. So let's talk about what we do have available in the tool today. And I'm going to be showing you this live in the application. So don't worry, these are just some slides to sort of whet your appetite, as it were. Everything you see today is available in Spira 8.5 and Rapise 8.3, which are generally available. There's some slides I do have on some functionality that's coming in the future. I may be able to show some of that live as well. We'll see how that goes. So this just for those who are not as familiar with the company, this is our entire product suite. We have our Spira platform in the middle, which is our lifecycle management platform. Spira Plan, Spira Team, and Spira Test are different flavors. I'll be showing you in the Spira edition some of the functionality around those tasks I identified for generating tasks, generating test cases, identifying risks, BDD scenarios, all of that management side of things. In the automation side, we'll then go to the bottom part of this diagram to our Rapise test automation tool. A lot of test automation tools out there are starting to add AI functionality. We've been working with some of our larger customers to road test the functionality, and we believe we have some really unique and powerful offerings that are live today. Plus, there's some new functionality we have just released, which is still cutting edge, which I'll talk about. Okay. In general, many of these AI functions we are going to be showing you are available in Spira as an add-on through our Spira app platform. We've done that because we know that many of our customers have compliance rules around using AI. So it's an opt-in functionality right now. You don't have AI turned on by default. It's something you will opt into for your safety. We also do support different models and different providers. Our strategic partner is AWS, AWS Bedrock. We're using primarily the Claude and Llama models within their suite. They just announced last week at reInvent that they are releasing the Nova platform of models, foundational models. We are also looking at those as well. So those may be more cost effective in the long term, but we are seeing great results with Llama, Claude, and potentially Nova, but we've just started our exploration there. If you are an Azure customer, don't worry. We do have equivalent functionality for Microsoft Azure, OpenAI. And if you have neither of these platforms, we do work with the regular OpenAI, the one that powers ChatGPT as well. So you've got lots of different options from a language model and provider standpoint. We believe in giving you this flexibility of which models because different customers have different compliance needs, different platforms they're using. We want to give you the control to have AI, but have it on your terms. Okay, so these are the examples we'll be using around using AWS, but it's going to be similar for the other models. You pick your model, you choose the some of the configuration settings. One of the things you'll notice when you use AI a lot is something called temperature. Temperature is the, I guess, creativity of the model. How concrete do you want the answers? How much interpretation, imagination, hallucination possibly do you want? So you can configure these settings to change how the models behave. You can also use different models. I'm going to be using for our Spira platform the Claude 3 Haiku model. It's a fast, relatively cheap model, great for text. When I use Rapise, our automation tool, I'll be using Claude 3.5 Sonnet, which is a more sophisticated, more expensive model, but really good at vision and more multimodal. So that's one of the things to bear in mind. There are different models available from each of these platforms, and they're good at different things. Right now, we let you select the model. As we evolve our functionality, the intention is to have some intelligence in our platform to actually dynamically choose from the models available based on the task. So eventually, you'll see some of this go away and be replaced by effectively a model selector that will do it based on tasks. Other things you're going to see in AI will be things called agentic workflow, where you have AI do things as well as tell you things. So AI is evolving very fast, and we recognize that what we see today will be changing as we release new functionality. Again, as we go through this talk, please feel to put any questions in the quick Q&A box. I will check questions at the end of each section before we move on to the live demo. So that's how you set things up in our platform, set up the model, set what you're going to be using. And then once you've done that, I'll be showing you in our Spire platform how you can use the AI functionality to generate common artifacts in the system. So typically in Spire, you would take a requirement, you would write test cases, you'd write tasks, you would generate BDD scenarios, you would identify risks. The task might get pushed to Jira, things like that. So depending on you, and then you might then want to automate some of the test cases. We're going to use AI to speed up all of those things. Now, these things alone, if you did all of this, you took a user story or requirement, and you completed all of the typical tasks in the project management lifecycle, it would take you maybe 4 or 5 hours, maybe a day to do that. With the AI, it takes minutes, and now you're reviewing it. What our teams have also said is it's not just the speed of the generation, which is great. It saves them a lot of time. It's much quicker to review something and edit it than start from scratch. The tyranny of the blank page. The other thing we found is that when it generates test cases, we'll see this live. It generates a bunch of different test cases, and it may generate some that you would have thought of, but it saves you some time in creating them. It will probably create a couple that aren't appropriate. You can just delete them. And it also will find one or two things that you didn't think about. And for many people, the value is that piece as well. It's not just that it saves you time, but it finds edge cases that you may have missed. And that's invaluable. That's improving the quality, not just the productivity. Then we'll talk about automated testing using the Rapise platform. And in Rapise, we'll be using a couple of different ways of AI. We can use it interactively as an assistant, which I'll show you. You can also use it to write your tests natively in AI. It can also be used to generate test data. And I'll show you some of this functionality. This is what we're calling version 1 functionality. That's why I mentioned earlier on version 1, version 2. This is the take natural language and turn it into an automated test. This is great. I mean, it's definitely much better than writing lots and lots of Selenium by hand, which we've all done, and then finding XPath and CSS, and it's like, oh my God, why am I doing all this work? Why can't someone do that for me? It's really good at doing that. But that's the first generation. The next generation of AI is even more than that. We'll come to that in a second. We'll also show you how you can use the assistant interactive like this to generate tests. We'll also show you how you can write tests natively in natural language like you're seeing here, and that becomes your test. So you don't have to manage test scripts. You can simply write natural language, and then it will automatically generate tests based on that as it's running implicitly. But there's also one level beyond that, what we're calling Generation 2 functionality. Now, this is the new AI robot feature, and it's using the latest Claude 3.5 Sonnet v2, which I'm afraid is a bit of a mouthful, model. And this model is what's called a large action model. It's more sophisticated than the other AI models. Not only can it generate text and generate test automation code and test automation scripts and actions, which we were showing you already, it can actually take action itself. And so it can control different devices. And so we're using this with additional prompts to be able to actually have it control, for example, a web browser. And in doing so, the main benefit you're going to see is that it can actually control the browser without an explicit, highly descriptive test. You can talk to it, write more like you would tell a manual test or a human test, I should say. I want you to test this functionality. I'm not exactly going to tell you the steps. I'm just going to tell you the outcome, and it will do it for you. So this is still relatively new, and I would say it's still a little slow and probably a little expensive in terms of the AI cost. As the cost comes down, this is going to change, and the speed goes up. This is going to change automated testing forever. It's going to change how we do automated testing. But let's get to that. That's what's currently available. That's all live today. What's coming in the future? We're looking at working on some functionality to help you optimize your testing strategy by looking at the code that you commit and figuring out which test to run. So for example, if you commit some code on the left, make a change, Wouldn't it be great if the system could tell you, based on the code you committed, of your 10,000 tests in your test suite, these 50 tests are the ones that you should run based on the risk of the code breaking, using historical patterns. So this is a machine learning application rather than Gen AI, and we're looking at using that to improve your test optimization. I'm not going to show you that today, but we do have a video which you can view on our Inflectricon hub showing this in action. This same video also includes a section on identifying flaky tests, where you have flaky tests that happen, and wouldn't it be great if you could figure those out and then fix those and separate those from the regular tests? So flaky app or flaky test? Be nice to know which it is, and this helps you identify which is which. So that's a separate video you can watch. I'm not going to be going into that today, just from a time standpoint. The other thing I will be showing you is another piece of cool functionality we're releasing. It's not yet on general release. It's with our partner QRA. They have functionality called QV Scribe that we're embedding in Spira, and that's going to let you improve your requirements. And you might think, why is this so important? Well, if we're saying that requirements are often, well, if you look at the studies, requirements are often the cause of software failures. If we don't know what we're writing, how to build it correctly. People aren't very good at requirements writing. And if we're using AI to help doing some of the writing, and if we're going to use AI to generate the test cases from requirements and tasks and all the rest of it, if the source of truth, if that requirement that we start with is not good, everything else we generate is going to be worse. So it does show that the importance of good requirements is only going to get more important. And AI can help us with that. So this is a requirements analysis AI assistant. You can see it here. It reviews your requirements and gives you feedback on whether it's well written, is it consistent with other requirements you've already written somewhere else in the same project, in the same system. What's the quality with it? Are the key nouns you're using? Are those nouns the same as other requirements nouns? Is there ambiguity? So it helps you improve the requirement and identify some of the key terminology being used to ensure consistency, and also find related requirements more easily in the application. So it helps you improve your requirements, improve consistency of the requirements, also build a taxonomy around your requirements as well. And this is typically a tedious task. And so it really helps you do that. And especially if you're coming from a world of more, user stories, more agile, one of the challenges is you often do need more sophisticated requirements when you get into testing and compliance. Wouldn't it be great if you could take a user story, have the AI help you write that, and then have AI help you review that, and then build it, code it, test it, release it, and speed everything up and have high quality? Well, this will let you do that. So that's what we'll be showing today. Before we go into that, let me just check if there's any questions. No questions so far. Okay, feel free to write questions in the Q&A box. Happy to answer those. Yep, nothing in the chat. So that's good. We'll keep going. So where are we headed in the future? What's the plan? What's the vision like? And I'm going to several conferences next year talking about these topics of AI and how will it change software development? How will it change software testing? Well, no one's entirely sure, but it is going to change a lot. If you look at some of the other industries that have been impacted by Gen AI, if you look at the search industry, I mean, people are no longer searching on Google; they're searching through ChatGPT, or they're using Google but using the overviews. It's changing it's changing the search industry and the marketing industry. These are some of the early adopters of AI. We've seen massive changes in how content is written, how people search for it. All of the search engine, SEO, SEM, go-to-market, SaaS, everything on the business side, marketing side has changed dramatically in the last 6 months. Without going into a digression on that, it has changed how we do software, software marketing, software selling. So in the development world, we're seeing massive changes in development. It's changing how we're going to do development and how we're going to do testing, and it will be very different next year and the year after than it has been. So a lot of the things that we've typically done, and as I said, 5% of developers' time is spent on coding. A lot of things that are manual and tedious are going to be done with AI. For example, AI like Amazon Q can now do migrations from one platform to another. So if you have a .NET application that you want to be .NET Core, or a Python app that you want to be in Ruby, or the reverse, or whatever it is, a lot of these sort of migration projects that would take teams of 20, 30 people are now being done by AI. Documentation, which no one likes doing, AI can help with that as well. We use that in that already. Unit tests. Someone writes a function, maybe AI writes the function. Who writes the unit test for it? Developers hate running unit tests. If they write them, they're terrible because it's the happy path only. Generating every permutation of input parameter, null variables, non-null, strings that are too long, special characters. You think of all those weird combinations. We don't do that at the unit test level consistently across every function because it's a pain in the neck. It takes forever. AI can do that, doesn't sleep, doesn't get tired. So AI is really changing a lot of the manual, tedious work that developers are using. But ultimately, as humans and as the quality, as quality engineers, quality managers, to product owners, VPs of IT, CIOs, CTOs, our responsibility is still to deliver high quality software that is fit for purpose. And I do think when we talk about quality, we often used to talk about does the software work? I.e., is it tested? And I think quality is changing. And so, as a quality professional, it isn't that we'll be using a lot of manual tools or scripts or code or even manual tests to does the software literally work? AI is going to do a lot of that for us. We'll be looking at how do we interpret what the AI is telling us, understanding is the quality of the software fit for purpose? Is it usable? Is it accessible? Is it reliable? Is it friendly? Is it going to deliver better business results than my competitor's equivalent functionality? I mean, as software is being developed faster and faster, more and more companies can innovate faster. So your moat around your company in terms of what you offer in your product and service is smaller. So you need to innovate faster. And to innovate means you have to deliver a high quality user experience. And when we talk about testing and quality, a lot of this is going to be on the human side of things. So the machines and AI can help with that too. They can do usability testing. They can look at screens and give you, quality scores. So as humans and testers and quality professionals, we'll be using a variety of these AI tools to help understand the quality at a wider sense of our software. See a QA. So a question came up. Um, so the question is, we're using AI Spire owner Ps. If any need to change in the customer requirements, is there a place to handle the human? Have you got my question? Okay. So the question is, I guess, if there's a change in the requirements, how do we handle that? That's a great question. And change of requirements is something that happens a lot, especially with Agile. We encourage that. We don't want requirements to be set in stone. So as requirements change, how do we understand the impact of that? I don't have an easy answer right this minute for that, but I would say we as vendors and sort of like Inflectro, we need to find ways to give you tools to understand if there's a change in requirements. First of all, what's the impact of that change? And AI machine learning can do that. So some of the things we're looking at improving on our platform are we're calling it Project Insight will be if you say, I want to change this requirement from A to B, then I want to be able to automatically have an impact analysis and say changing the requirement in this way will impact usability in this way, quality, security, having the tools give you the impact analysis on a potential change, and then automated tools like Rapise that can do some of the testing to speed that up. I think AI is going to need to be part of that conversation. We don't have that functionality yet, but that's somewhere where we're going is, as you ask to make changes, can't the AI tell me what the impact is across all the different dimensions of quality and delivery? And will it change my timeline from a project management standpoint? So AI definitely can help with that, understanding a change and what's the impact across all those different domains. Next slide. One thing I would mention is for those who look at the movie industry, it's a similar analogy, right? You can use AI right now to write scripts. You can go to ChatGPT, write me a movie script. You can use tools like Sora and other video tools and picture tools to generate picture boards or movies. You've seen people generate AI movies. I've seen a tool that can generate a podcast from a white paper and the reverse. So there's lots and lots of tools that can make content in format A into format B. But is it actually any good? Like, is it a movie you want to watch? Is it real? Does it feel real? And even if it's real, is it something that's actually compelling? So, one of the challenges was you've got tools that can turn a white paper into a podcast. Well, I started listening to the podcast and it was pretty good. It sounded quite natural. But at some point, I'm like, this is taking forever. Maybe I can transcribe this into a document to read quickly. Well, at that point, I've taken a white paper that I've turned into a podcast. I've turned back into a white paper. So at some point, it just becomes content translation. So will we find, well, just because it can convert it and do it and make it doesn't mean it's any good. So when we talk about a movie script, it's the same thing. Making a movie that someone's going to pay money to go see is not the same thing as using AI to make a movie. So even though we might use AI tools in the movie industry, there's still going to be people whose job is to look at a movie, assess it. Is it artistic? Is it funny? Is it compelling? The test audiences effectively. That's really important. Is it actually going to be correct? Is it going to do weird things that are not, violate the laws of physics? Is it going to be culturally appropriate? Is it going to be in the right setting? For example, if you remember, this is a famous episode of Game of Thrones. A Starbucks coffee cup made it into the final print in one of the scenes, and clearly the medieval period in a far-flung place is not going to hopefully contain Starbucks coffee cups or whatever brand it was. And that should have been caught, but it wasn't. Um, Again, those kinds of things. Is it something that people are going to want to watch? So I think if you think of that back in the software space, even though the movie might physically exist and might be correct, if it's completely boring, no one wants to watch it. It's not fit for purpose. Back in the software world, if AI is going to help us make software that maybe works, but it's so many clicks and so unusable, that's not quality software. So as QA professionals, we'll be using AI to understand how to use these tools to improve the quality. So enough talking. That's some of the cool stuff that AI is going to help us do. That's where the industry is going. I think a lot less time writing scripts, a lot less time writing test cases, a lot less time, looking at locators or objects or doing stuff with a browser, a lot more time interpreting results, a lot more time, using tools, trying different scenarios, a lot more what if scenarios, a lot more heuristics. That's what we'll be doing a lot more of. First thing we're going to talk about is the AI functionality that we have in our Spira platform. As I mentioned, this is generative AI, and it's really used to speed up the productivity of generating artifacts in the system. So, for example, I've done this before. You can see some other examples, so no worries. Let's talk about a simple use case or a user story from a consumer application. When you talk about AI, we are using in this case, an untrained or just a foundational model. It's not been trained on our data in any specific way. This is a really good use case when you have an application that's fairly understandable and mainstream that an AI model would know about. So let's say it's going to be a consumer flight tracking system or flight reserving system like an Expedia or other tools like that, Amex Travel, whatever you're using, Kayak. So pretend that's the platform. And so I'm going to have a new requirement or user story, and it'll be as a customer, I want to book a flight between two cities. And there might be another requirement. There might be I want to book a flight that's multi-city or a one-way. I mean, there's different requirements, and I can help you with that. In the settings, I've set this up ahead of time. It's got some configuration. So just to jump over here quickly, in the settings, I've turned on some of the features. So right now, if I go here to my Spira app, I'm telling it to generate test steps. I'm using the Anthropic Claude model. I could also use Llama. I'm ignoring the descriptions because I'm not writing any descriptions, and some other settings and things in here and the various prompts. So you can configure and modify the prompts. There's some magic behind this. You don't generally need to do that. You can just generally use it out of the box and just maybe check this box. So now I've got my requirement. First thing I might want to do is let me change the type. I think I might want to come up with some scenarios because I've only talked about the positive case, which is booking a flight. Obviously, that can fail. There can be negative cases. So rather than writing those by hand, let me use the AI to generate my BDD scenarios. So it's going out to the large language model and it's generating a prompt behind the scenes. And it's basically using this name. I told it not to bother the description because I haven't entered one. There is the option to give it a description as well. Again, and then that will be used. And now it's generating my BDD scenario. So I hit the refresh. I'm going to scroll down and I've got my scenario. So these are some scenarios which make up they're written in the Gherkin syntax. And again, these are things that I could write manually. It would take me probably an hour, depending how fast I am. And I still might want to go through these and edit these, talk about the combination, selecting a flight, details. It's given me a step-by-step set of scenarios. I might want to change this based on what it generated and regenerate it. I could do that very easily. You saw how quick it was. If I wanted to generate one that was between one city or a multi-city, it's super easy. I could even just create a new requirement and clone it and do the exact same thing. So it's really quick at generating content. It saves you a lot of time. Now we've got our scenario. Well, we probably want to build that, right? We should build the functionality. So let me go into the tasks and let me generate some potential development tasks that go with it. So I'm doing that right now. And it runs in the background and it will generate some tasks. And if I go here, there's some development tasks. Each task, by the way, is not just a title, it also includes some implementation details. So let's look at some of these. Payment processing, that's always something that's kind of fun. So let's look at that one. I'm going to control click, bring it up over here. It wrote a task to implement payment processing, and it gave me implement payment processing. It's wrote a payment gateway to allow customers to securely pay for their flight bookings. Okay, that makes sense. Um, I can even generate some sample code with this if you want, and it will generate that using a language of your choice. Some of this stuff, depending on the language, it may come up with good code or not so good code. It really depends. We could try that. Let's say create that in Java. Hit create. Did that. I can also generate unit tests if I go there. So there's my payment gateway. Go there. I'll open another tab, view item. And there is my code. So it's going to do some sample code for a payment gateway, like a stub. It's great, gives you a template to work with. This is already in the Spiro document repository, so you could access this. We could also push into a Git repo as well. If you wanted a unit test with it, there's also the option that you saw to generate this same code with a unit test. So imagine you could do that for all of the different tasks. There were about 8 different tasks. From this, you've now got, for one requirement, you've got 8 tasks, each one with some lines of sample code, all ready to start implementing with. And we've got some scenarios. So from a development and planning standpoint, we've really got a pretty good structure for this one feature. And that took me about 2 minutes, which is a great time saver. But testing, we talked about testing and validation, and that's a problem. So how can we solve that problem? Well, very easy. We go into test coverage, and we do the same thing, but we now say, generate test cases. Sharing those test cases. I'm going to let it run for a little bit. Okay, it's running now. Okay, it's finished. So now we're going to refresh, and it generated some test cases. Oh, and there we go, and the test steps to go with it. You can change the prompt as well. Right now, I think it's generating about 5 test cases. You can change the prompt to say generate at least 10 or at least 20. There's ways to customize the prompt to increase the number. That's one thing with AI. It can be lazy, meaning it doesn't generate as much as you want sometimes. But it's generated in this case a pretty good set. It's got first of all, the positive case, book a flight between 2 cities, and it works. Let's try booking a flight between an invalid city and a valid city. Let's try booking a flight with the same origin and destination. We often forget about this one. Like, I want to fly from Atlanta to Atlanta. Much as I like Atlanta, that's probably not particularly useful. I think during the COVID, they actually had some flights that flew from one place back to the same place just because people missed traveling. Sort of funny. Book a flight between 2 cities, and book a flight with no origin or no destination city. So mixture of positive and negative use cases. Uh, let's look at one of them just to see what it might look like. Let's take a positive case. As you can see, not only is it written the actual test case name, which is right here, it doesn't do a description. I chose to create detailed test steps. So it did generate them. Look, it's given me sample data, New York to LA, some times, passengers, some other different ones, a checkout, services, cancellation. I mean, it's quite a sophisticated test case with sample data. Now, again, you would go through this line by line, check it, make edits. But think about this. How much time has this saved you? This was probably an hour of your time. This is now a few minutes of your time. And if you're going to go through this level of detail with test data, probably several hours. And then again, the same thing with the other tests. If I go back to my requirement and I just choose an invalid one, let's look at this one. We've got the same level of detail. It's now, from Neverland to Atlantis. That's funny. And clearly arriving in Wonderland, and so Narnia, Tatooine. It's got some different examples. Vulcan, quite creative. Hogwarts to Rivendell. I guess they're in different genres. They kind of you can't fly from one genre to another. It's quite funny. And it's giving you some suggestions about the error message you should be generating. So again, some good sample use cases there from a negative example, and so on. So we've now got test cases both for positive and negative for this one requirement. This again is saving you hours and hours of time. Now, the other thing we often think about is risk. And I mentioned at the beginning about risk in our company tagline. So we have this requirement, we have these test cases. One thing we're seeing more and more with AI is testing isn't just about, as I mentioned, it isn't just about does it follow the path and do what it's expected? Is it fit for purpose? But also, if you've got a system that was built using AI itself, with training data, you have to think about what is the risk profile of that system because the requirements are not as deterministic as they were before. So what could happen? So it's not just about what has happened and pass or fail. It's also about what could happen. And with AI, that's going to be more and more important. So luckily, Spyro does come with a built-in risk management module, which is right here. And people use that to identify the risks with the requirements and then do risk-based testing. But as we all know, identifying risks and brainstorming takes a lot of time. It's a pain in the butt, and people don't like doing it. So we often don't do it, and then it bites us. So what if we could automate that as well? Well, we can. So we can now identify what possible risks could occur with this particular feature. And AI is going to identify those potential risks for us. Okay, let's go in here. And here are some different risks. Error handling and user experience, integration with third-party systems, data security, availability. Let's look at one of these and drill down on it. So let's look at user experience. We talked about fitness for purpose being a user experience function, so that's true. So we talk about what's the risk? Well, the risk is if I go to overview, the AI has identified that the software should provide clear and helpful messages and good user experience so people like the system. Okay, so that's great. So I've got my risk. It's linked back to my requirement. I could build a test plan to test for this and reduce my risk, which is great. But what other ways could I potentially reduce the risk? I'm sure we could brainstorm some on the chat, but rather than do that, let's use AI to help us and let's think of some mitigations. So the good news is the AI can also help us with the mitigations. So not only does it find the risks, it fixes the risks too, or mitigates them, I wouldn't say fix. And so it's going to generate those. And here we go. And here are our mitigations. And it's got some really good examples: robust error handling, gather user feedback, testing, inline help, contextual help, support resources, live chat, that kind of stuff. I mean, again, some of these maybe don't apply. You could delete them, others do. But it's giving you a good assessment and a good assortment of different mitigations. If you chose a different one, like a security vulnerability risk, there will be different mitigations it would suggest. So that's really exciting. You can now generate mitigations from your risks and tie those back to your requirements. So that's a quick overview of the Spyro functionality. There's some other parts as well. If you had, for example, a test case and you wrote a test case, but it didn't have any steps, let's just say I, wrote a new test and I've not read about requirements. I've just got a test case and the test would be, oh, let me clear my filters. There it is. And I just say, verify that a user can log in to Expedia.com. Let's just say that's what I've been asked to test. And I need to increase my number of rows. I've got too many tests here. Look at that. And in fact, can't find it. So oh, did I create it? Hold on. Oh wow, I've got way too many. Loads. Gee whiz. No wonder. I think that's all of them. Yeah, there it is. So I've got my test. Now I want to be able to generate my test. The great thing is if I have a test case and I haven't got requirements, I can always just generate the steps here. So I can click the button and that's going to generate now steps for my existing test case. So don't worry if you haven't got requirements, you've got some test cases and people have written them, but there's no steps. It's too much work to create steps, or the application is changing frequently. Well, you could use this to write the steps dynamically. You could actually say, every time we change the application, I'll delete all the steps and just regenerate them. Here we go. So here's an example here of the steps to logging into Expedia. That's pretty cool. So great time saving, great functionality. And of course, if you don't have any requirements, which I hope no one has that problem, but we do come across it, you can reverse engineer requirements from your test case as well. And that will generate a requirement from a test case. So we can go both directions. Requirements to tests or tests back to requirements. And it's created a very simple requirement like that. So that's the power of Gen AI in Spyro to generate artifacts. There's more functionality. That's just a great sort of scratch of the surface. Let's talk about test automation. Before I do that, let's just see if there are any other questions. Let me see in the Q&A. Hold on. In Gmail, there is no longer available as of now. People who read the sent mail are still not getting any acknowledgement. I I don't know why that's not available. That's a good question. So the question is, I guess, if someone changes a feature like in Gmail, they remove the sent mail. Gen AI can Gen AI assess the impact of that? Now that's a good. I actually use Gmail, and I do find that annoying. I created a filter in Gmail to actually put the sent mail to create a copy in sent mail for my record. So I fixed that myself using a Gmail filter. But the question I think is more metaphysical around the requirements. If you have a requirement for a feature and it gets removed or changed, like this one, no one did an impact of how that affects the different use cases. And so if a requirement's being removed, we could use Spira to say, what are the risks of doing that? So maybe the feature was remove the mail you sent to from your account from the sent mail because it's redundant. And our AI would have said one of the risks of that is you lose the audit trail of what you've sent, and the mitigation might be have a feature flag that you could turn on or off. So that's a really good example of a case where this would have helped out had Google been using it. If you're watching this, Google, feel free. Now let's talk about automated testing, which is we've got these test cases that we've written. They've got test steps, so they look something like this. How do we automate them? Well, traditionally, we could record a test case. We can go into our automation tool, which is right here. And I'm just going to hide yep. And if you go into our automation tool, you've got the option. Let me go to a simple test from before. Here we go. And you could write a test case that looks like this. So, log in, set the text in the username. This is the login scenario. So I'm going to open up an application. I'm going to log in. I'm going to put the username and password. I'm going to click, wait 5 seconds, and log out. That's the use case. This is my traditional codeless automation. And the traditional codeless automation is a series of steps that uses objects that link to things in the user interface. So if I go into my objects right here, you'll see I've got, for example, no, right here, the different screens. I've got my different links, buttons, login buttons, submit buttons, text boxes to put the login and password, all the various things you'd expect for a test automation tool that's testing a UI. And so you would manually create all this based on the manual test. In Rapise, you have the option of viewing the manual test from Spira, of course, and then you can see that in Rapise and automate it. But it's still a human task to take effectively test that looks like this, which is natural language, which is similar to what Spira has over here, and turn that into something that a computer understands over here. So how can we shorten that cycle? How can we turn natural language into code? Well, guess what? We have a solution. It's called AI. So in the AI, you can go in and like we showed before, there's some settings. You use different models. For this example, I'm using the Claude 3.5 Sonnet model, which is one of the more advanced models. In the Rapise, you can make sure the connectivity is good. Do that. Once you've done that, you can then go into the AI dashboard and you can use the chat feature. In Rapise, it's a bit more interactive, and you could do something like, I've obviously done this before, so I'll do it again to show you, type in it in natural language like this. And it's going to basically look at the application, in this case, it's the URL, and it's going to look at the different objects that it sees on the page, and it will build you a test script that looks something like that. And if you're happy with it, you can simply use the apply button to put it into your test. So let's do that by going back to my test case. I've got it already up the top, but I'm just going to show you it from scratch. I'll put it underneath. I just go apply, zoom window out the way, hit apply. You can obviously edit it, and it then will apply into the grid here. So easy enough to basically do that, just apply. If you want to change it, there's also the edit and apply option where you can make changes and then apply it. And that way gives you the option of both editing it and putting it in here. So we do give the option of just using it as written or making changes. Now, the other possibility, so that's basically turning natural language, which is this, into automation script, which is this. Again, saves a lot of time, highly productive. The other thing we found is that, well, that's great, but then I still have to maintain this script, which is here. What if I didn't have to maintain the script? What if the AI, the natural language, is the script? Now, that's also possible. So in which case, you can use our new AI object that we have, which you see right here, and it's a new top-level object. Instead of using like a login button or link, a username field, a password field, you're now using the natural language as the steps. And instead, you can actually then just go here and play these. And what it's doing behind the scenes is it's implicitly converting this into the script before it plays it, and then it plays it. So it's basically similar, but instead of you having to maintain, you're now having it done automatically. like so it shows it down here. And you might think, what's the benefit of that? Well, the benefit of that is that whereas before, if you have to make a change, like here's the different parts of it. If you, for example, that's the waiting 5 seconds, that's the logging out, and then this is the logging in. So it's all separated out here, and you can see each part. The benefit is this is implicit. So if my application changes, or if I want to wait 10 seconds, or instead of logging out, I want to do something else, I don't have to maintain this script. I'm just maintaining this. And as long as this matches what I'm intending to do, it will work. So you're reducing the maintenance of maintaining these, and this is only 8 lines, but imagine this was thousands of lines of script. Suddenly you replace 1,000 lines of script with probably 20 lines of natural language, and that is now much simpler to maintain. Now, one thing I want to be really clear though is the in this is still the first generation of AI, because this here, if you look at what it's doing, it is still ultimately using login, submit, logout buttons, username and password. It is using the objects in the application. So Rapise can scan the application and it can find these objects on the page. And I could even show you the application we're using. It's the library information system. It looks like this. So ahead of time, I go in Rapise and I simply say scan the page, click point over the objects that I care about. It adds all these objects to this tree, and then they can be used. So there's a two-step process. I first get the application page open, I scan the page, get the objects that you see here by clicking on the ones that are important, ignoring the ones that are not, and then I use the AI to have it run the test. Now, what if we could get rid of that first part? What if we don't need all these objects? These are ultimately objects that do point to something on the page, and we do a functionality in Rapise to dynamically learn these so we get the right ones and they're maintainable. But ultimately, we're still reliant on the fact that we're connecting to a web browser, not the same way that a human is. As a human, I look at the page and I infer what I need to do based on what I see. I'm with this generation of AI, I'm taking natural language and I'm turning it into script dynamically. I'm looking at objects on the page, which I've learned dynamically, and I'm making it much faster, but I'm still doing it using effectively XPath or CSS. I'm still connecting to an object on the page like a robot, not like a human. And so there's differences in behavior. It also means I have to write things quite explicitly. I'm still saying log in, wait 5 seconds, or I might say click on the book link. Like if I wanted to, for example, automate over here in Chrome, let's say I want to edit a book, I would go in here and I'd say click on the book management, enter your login and password. I still have to write it very much like I'm telling a machine. If I was telling you as a human, I wouldn't do that. I'd just say, oh, can you edit a book in the application? And you'd infer that I meant log in. You'd infer that I meant click on the book in navigation, and you'd infer that I meant click on the edit button for the book. It's inferred because I understand the context. What if AI could do that? And that's where the version 2 AI comes in. So version 2 AI, which is literally half the press of a few weeks ago, is let's go in here to the other test I have, which is using the robot right here. And this is my test. I played it earlier on, but let's go back over here. It looks like this. That's my test. I'm logging in as the login and password, and I'm changing the genre of the book from Jane Eyre, from whatever it is today to detective fiction. I don't say click on the book link. I don't say click on the navigation. It's much more high level, and I'm asking it to infer what is going on. And if I play this, I'll play the whole test. So just hit play and make sure the browser's good. Let's do that. And it's actually a different version of this application that's going to pop up. It's a slightly newer book management app. I think it's written in React. So you'll see it come up like this. And it's going to hopefully, if it works correctly, it's going to log in. Now with AI, there's always the chance it's literally inferring in real time. It's a bit slower too, you notice. It's not as fast as normally test automation because I'm using AI in real time to actually infer what's on the page. It's logging in. It's now inferring. I told it to change the genre of a book. I didn't say click on books. I didn't say click on authors. I just said change the book. So now it infers that book, Jane Eyre, is in the book section. I didn't say click on edit, show, or delete. Hopefully it doesn't do delete. I just said change it. It inferred the edit is the right thing to do. And I told it the genre should be detective fiction. I didn't say it to drop down. I didn't say it to pick list. I just said change the genre. It has to infer what that means and where it is. And it's going to save it, hopefully. I didn't see say save. I assume that save is obvious, but it may not be. And that's it. It did it. I did try this test once before, and I forgot to change it when if you don't log out, it keeps the data. So I didn't tell it to change the genre. I just I left this. I just said make sure the genre is detective fiction. Well, I forgot to change the genre back before I played the test the second time, and in my demo, it didn't do anything. It just went to the page and said I'm done, and it's successful because it had inferred that because the genre was already detective fiction, it didn't need to do anything, which is actually kind of correct, but it's also kind of not correct because it should have warned me and said that the test is not right. As a human would probably say something like, "Oh, that test doesn't make sense. It should be blocked because the data is not right," or "Why am I changing something to the same thing?" So that's one thing we have to think about is as we start to use AI in testing, it's incredibly powerful. Look at that. I didn't have to tell it any of the steps. There's no objects here. I can expand it. There's no objects, no hidden XPath or CSS. It's actually using vision to do all this. So it's actually looking at the page, and if you actually look at the report, you can see here it's moving the mouse to certain coordinates on the page. It's acting like a human. It's seeing the page. But it does infer as it goes, and that means it might make different inferences than you're thinking. So it might not test exactly the way you think. It might find things you didn't realize, like an exploratory tester. If the navigation was broken, but there's a secondary navigation link that does work, it's going to find a way to get to that page for you. So it will find things you didn't expect. So it's much more like a human tester, which is good and bad. So what we imagine in the future will be this type of autonomous testing, as we're calling it, may not be the only testing because a good old-fashioned regression test, like I showed you before, where AI is taking natural language and writing a test, is much more prescriptive. It's more like a regression test. It will fail if the application is somewhat very different, but it will be much faster to write. This autonomous test, where it's going out there as a robot and inferring, is much more like an exploratory test. And we think you'll need both because one tells you one thing and one tells you another. And as a human, you can put these two together and infer the application works as written, but maybe there's a usability issue because the robot succeeded, but the regression test failed. Or vice versa. The page is not working as designed, but actually it's better than designed. Maybe we should change the requirement. Maybe it's working in a way that we didn't expect, but it's an improvement, which a human would tell you. The AI can tell you that too. So it's amazingly powerful. This new inference type of robot that we have available. So you can use AI to basically take a test like this, with written in natural language that could come from Spira and play it back using AI. Much, much more efficient. If your application changes, if the word edit changed to update on the navigation, if you go back here, it still works. Like I've not hard coded the word edit or show. I've not hard coded this. This is a navigation bar. It could be an icon. I've just told it what to do, and it has figured out how to do it. So compared to the more brittle ways we do testing today, incredibly more efficient, incredibly useful way of finding out how your application is going to work with a real user, but also if you're using SAP, Citrix, or some technologies that are harder to automate, it's no problem as long as you can see it, or geospatial even. As long as you can see it on a screen, the AI can test it. It doesn't require locators, it doesn't require accessibility. So a lot of the impediments to automation that we have today are going away because it's vision based. It can see and act like a human on any application. We're running short of time. So the last thing I wanted to show you very quickly, I'll just give you a preview of it, is if we go back into Spira, I mentioned at the beginning about requirements analysis. So this is the requirements analysis tool that we'll be releasing next year. It's not yet available. It is just the beta version. You can go into its core QV Scribe. It's going to be natively available in the Spira platform using our Spira apps platform. You can go in here and you can write a requirement. For example, the cruise control shall compute the distance in seconds, and you can analyze it and it will give you analysis like this. In this case, it gave me a score of 5 out of 5. It's a well-written requirement. It's got good nouns. It uses the right words. If I choose a different one, let's see one that's maybe not as good. Here we go. This one's got a score of 1 out of 5. Ooh, not so good. And you can see it's highlighted some of the issues. There's no imperatives. It doesn't say the driver should. It just says it has. And so it's telling us here, there's a positive example and there's a negative example. So here's the fact that we're missing the word shall. So if and then it suggests here how you can change it. And it marks up where the issue is. And it also mentions superfluous things. For example, ability to is superfluous. We don't need that word. It doesn't mean anything. It doesn't change something. So it's giving us examples of how to improve our requirement. If I go down here to another one that's marked as a 1, or actually marked as a 3, sorry, that's a 3 out of 5. You'll see what the issue is here. It's got a cross-referencing issue. It's using the word it. It is very dangerous because what is it? Distance from the ground, for example, or maybe it's from sea level. Which is it? Could be either, could be both. So it's giving us a warning that that's an ambiguous requirement and not concrete enough. So again, requirements analysis also benefiting from AI. You use this tool, you can either analyze a single requirement, or if you go to the list page, you can analyze many requirements by checking the boxes, and it will give you a bunch of scores you can see here. So you can see now you've got a score rating on the list page. And then if you go to your dashboard, there's also a new widget available right here. So hopefully it loads, and that will show you there we go. That will show you the count of requirements by score. So how many of our requirements are score 1? Unfortunately, 50%. 22% are score 3, and 27% are score 5. So we're doing okay, but we could do better. So in a real situation, you can go back, review the requirements, and get them all to score 5 before you actually have the AI use those to generate the test cases and the risks and all the other things I showed you. So that way, we're improving the quality right from the outset. So that's an overview of the AI functionality, where the industry is going. Let's talk about I've got some time for some Q&A. A question was, if JNA occurs 2 times, it might have a duplicate name. Yes, and the AI, if it's a second time, it wouldn't necessarily know which one to click on. Now, that's true for a human, by the way. It wouldn't know which one to click on. Actually, it might do both. So with AI, it is literally going to infer that what you told it. And so my guess is it might, we haven't tried it. It's a good test we could try out. If the application allows it, it would potentially edit both of them. An automated test, if you're doing it based on like an XPath, depending on if you learned the ID or the name or position, it could edit one, none, neither, both. Really depends. The AI is going to attempt to interpret what you said and come up with the best answer. That is a good point. In the chat, we have a few other things. Let me look in the chat window. Does the AI tool also build right tests and code if used differently? Are there any specific requirement for the tested use case? That's a complicated question. But basically, instead of Spira, the code is based on the name and description of the task that comes from the name and description of the test case of the requirement. So depending on the requirement name, it will write different test cases. From the test cases you can write, it will write then different code and different manual steps. From the automation side, it will depend a lot on what objects you've learned and then the test steps. The question from Stacy: does the automation speed increase over time? That's one of the things we're looking at. Right now, the automation speed of the inferred method using version 2 is slow because these models are slow, expensive. And we're using the latest model. It's Claude 3.5. It's looking at the application. And right now, I think we did some testing. We've been using this, for a month or so. I think it costs us about $35 in spend to do some basic, testing. So it's not super expensive, but it's more expensive if you have lots and lots of people running it. You probably wouldn't want to put this into a pipeline right now, running every single build. It's probably too expensive and slow for that. But as what we're seeing when we talk to Amazon is they're committed to getting the cost down and the speed up. At reInvent last week, they've just released their line of Nova models, which are similar to some of the Claude models. We've been doing some initial tests to see how good they are. Those will definitely be cheaper. And Amazon is also releasing its own range of chips, the Trainium and Inferium chips, as well as using NVIDIA chips. So what we're seeing in the industry is that, like a lot of new technology, right now it may be a little expensive, a little slow, but as the speed is going to go up and cost is going to go down, this ultimately will become the way we do testing. As of today, it's probably a little slow and a little expensive to be your primary or sole form of testing. That's why we have the V1 AI and the V2 AI. V1 is cheap, fast, repeatable. Right? It caches the results. It creates automated script. It's very repeatable, very fast. People are using that a lot in production today. The inferred technique is much more for exploratory testing. You wouldn't do that every build, but you would want to use that before you go live with the release. So I think like a lot of things, you would use version 1 in your CI pipeline, run it for your repeatable regression test, make sure the application works. Then I think you would incrementally do a version 2 kind of test, have it infer the information we're giving it, see what it finds, like an exploratory tester does today, and then you'll find your edge cases. You'll find some of the usability issues. So I do think right now, because of cost and speed, you'll use them both together. But over time, I do think the version 2 inferration method, visual method, is probably going to become the dominant one once speed and cost gets addressed. But it still right now is a little bit of a roadblock to its full usage in every single situation. So I think that's all the questions I have. So hopefully today was great. Thanks so much for attending. Have a great rest of the day, rest of the week. Thanks again, and have a great day.